All right. Now, for the very first question, let's go to one. Let me double check whether the sound is working. Okay, it's working. Which quantity with its unit is correct? Acceleration is not correct. Current ampere is not correct. Then electric potential is joules per coulomb. That is correct.
मैं कह रहा कि ये शीशे नहीं ले जाना अपने साथ नहीं बिल्कुल नहीं ले जाना
Now, which units are equivalent to each other? Newton meter and kg meters per second. Okay. Which are not equivalent to each other. Okay, let's try this. Kg meters per second square for force times meters. Okay, this is equivalent. Kg meters per second square times second. Okay, that's also equivalent. Joules kg meters per second square times meters times 1 upon second, that's also equivalent. Pascals is kg over meter cube times meters per second square times meters. Yeah, it should be kg meter minus 1 second minus 2, but it's wrong here. All right, now the next one. Which diagram does not represent two vectors as perpendicular components? So basically this will have perpendicular components like this, right? Somewhat like that. R has two perpendicular components, so it means that here it would be something like this, here it would be something like this, here it would be something like this, but here it would be like this, which is wrong because it doesn't give you the right direction, right? So C has to be the answer here. Now, which could reduce systematic errors? Systematic errors can be reduced by averaging, no. Reducing, careful calibration. Yes, that's correct. Reducing, no. Repeating, no. The power loss of P in the resistor is calculated this with percentage uncertainty in this is 2%. What is the percentage in P? So change in P, uncertainty P over P equals to uncertainty in voltage plus uncertainty in R over R. Because they're square, we'll multiply 2. So 2 times 3% plus this is 2%. So 268% should be the answer. Pretty easy. And now let's move forward. A lead sapphire is released from rest at point X, a long way above the surface of a planet. The sphere falls in vacuum. After it is fallen through vertical distance of 3. Assume acceleration free fall is constant. How far the sphere have fallen from point X at a time of 20 seconds after release. Okay. So first of all, we write SUV80. So it says the vertical distance was 3. The final velocity, initial velocity was 0. The final velocity we don't know. Acceleration is constant. We don't know this as well. What is the acceleration? And the time is 4 seconds. So it's best that we find the acceleration first. So S equals to UT plus half AT square. So this will be 3. This will be 0. This will be half. This will be A will be A and time will be 4 squared. So if we get the acceleration there, then we can actually use it to find other things as well. Now let's find 3 into 2 divided by 4 square. So acceleration is 0.375 meters per second square. Now we can use SUV-AT again. So it says how far the space traveled, point x, 20 seconds after release. So we want to find this. Initial velocity 0, this is not known, this is 0.375 and 20 seconds. So we'll use S equals to UT plus half AT squared. So S is what we need to find. This is 0, this is half, this is 0.375 times 20 whole squared. Now let's do this. 0.5 times 0.375 multiply by 20 square. So this is 75B. Pretty good actually. Now 7. Newton's third law describes forces on same type act on a pair is weight of the ball. Which arrow represents the other force? Weight, if you know this object is being pulled by earth, so object will pull earth by the same amount. That has to be the idea. Okay, so it has to be A. Then if you have any questions, please let me know. Okay, now a snowflake is falling from sky on a still day. The weight acts vertically downwards and air resistance acts vertically upwards. As the snowflake falls, air resistance increases until it is equal to weight and there is no resultant force acting on the snowflake. When the forces become equal, which statement is correct? When the forces become equal, the snowflake must move with constant velocity because it reaches terminal velocity. Then, two objects in isolated perfectly elastic collision. The velocities of objects before and after collisions are this. What is the speed v of y? Okay, so we could use take this side as positive, take this side as positive. So u1 plus v1 equals to u2 plus v2. Because we don't know the mass, we can't use the other things. So this is 20, this is plus 10, this is 12, and this is v2. So 30 minus 12 is v2. So 30 minus 12 has to be 18 then. Pretty good actually. This is easy. Okay, now a solid sphere which is less dense than water is held completely immersed in water few meters below the surface. The density of water is uniform. The sphere is released immediately after release. The sphere rises. Which row correctly describes? Okay, so the upthrust is always constant because it just it is basically dependent on change in volume, right? Which basically means that the resultant force would act when it is rising, right? So basically velocity is up, weight will be down, and drag will also act down. So slowly it will come to equilibrium, which means resultant force will keep on decreasing till it's 0. Now the diagram shows two parallel forces. Which statement is correct? X is equivalent to clockwise of X is equivalent to clockwise torque of 10 Newton meter. So okay, and a force of 20 Newton to the left, right? Okay, that clockwise, so this will turn it this way, this will turn it this way. This is clockwise, that's true. So here if we take it from the center, so this is going to be 25, this is going to be 25, so 40 times 25, this is 1000. Okay, they say find in meters, sorry, we have to do 0.25 then. So 0.25 times 40, that's 20, and the other one is 20 times 0.25, this is 20 times 0.25, this is 5, right? X is equivalent to a clockwise torque of this, okay, and the force of 20 newtons to the left. There is the resultant force is definitely 20 newtons here, but how is it equivalent to that? let's see. We take it from the center. It should pair of forces, right? 10. Wait a second. Let me see.
Sir, the first value is 10.
The first value is 10?
Yes.
How? How is it? Oh, no. Yeah. This value you mean?
No, 40 times by 0.25. You accidentally wrote 0.5 in the calculator, so it came out wrong.
Sorry. That's why I was so confused. Why is it giving me that? So this should be the right answer then. Okay, because the torque is clockwise. Now, then going to 12.
Wait,
Yes.
I don't get this.
Okay.
Where do you get the 0.25 from?
I took the moment about the center. You can take it from any point, okay? So about this center, this distance is 25, this distance is 25, right?
Yeah.
So the moment due to 40, which is the larger force, 40 times 0.25 is 10 Newton meter. Do you understand?
Yeah, got it.
So you have to take it from the center right here. Okay. Then going to 12, a heavy ball hanging from cable is held in equilibrium by a chain. Which vector shows three forces acting on the ball? So there is equilibrium. So there will be tension here. The weight will be here. There will be another tension this chain. So cable and tension in chain. Sorry, cable and chain. Okay. So this is right. Weight is down. Okay. So and tension chain is also in the right direction. It also makes a closed shape, which means that this is correct. Okay. Now, at sea level, the atmospheric pressure is 100 kilopascals and density is this. Assume the density of air decreases linearly with the height above sea level. What is the estimated total height of atmosphere based on this information? So assume that this is the surface of Earth, okay? And this is the top of atmosphere. And from here to here, you have, the density is 0 and 1.3 here, which means if it changes linearly, so average density is going to be 1.3 plus 0 divided by 2. 1.3 divided by 2 is, so average density is 0.65 kg per meter cube. Okay. So now the pressure here is 100 kilopascals. So 100,000 equals to 0.65 times 9.81 times the height. So it's 15,680. 15,680 is 15 kilometers or 16. That's fine. 15.6 is 16. 13 is B. Now, the train supply cold power station. The table shows quantity describing the operation of power station. Which expression gives the efficiency of power station? So power station average output, number of trains per day, mass of coal on train, energy of 1. Okay. So fine. Number of seconds in 1 day. Right. Interesting. What is the efficiency? So the input, first we'll try to find the input, okay? So input will be, so the mass of coal on one train is m times the number of trains are n. So that is the total mass. And then times the energy of 1 kg will give you the total energy, divided by number of seconds in 1 day would give you the total input, and output is just power, P. Okay, so output over input would be PS over MNE. PS over NME. A has to be the answer. Okay. Alright, this question was pretty strange. The piston in a gas supply pump has the area as this and moves a distance of 30. The piston moves the gas fixed temperature, fixed pressure. How much work is done? So pressure is work done is pressure times change in volume. So 4,000 times, this is in centimeter and this is also in centimeter. We need it converted into meters. So we can find the volume first, it doesn't matter. 500 times 30 would give us the volume. 500 times 30, so that's 15,000 centimeter cube. Okay, now 1 meter is equivalent to 10 raised to a minus 2 centimeter. A meter cube would be equivalent to 10 raised to a minus 6 centimeter cube. So we're going to replace this here. So 15,000 times 10 raised to a minus 6 would give us in meter cube. Okay, now 4,000 times 15,000 times 10 raised to power minus 6. So that's 60 joules. A. Pretty good. Now, then a steel ball is falling at constant speed in oil. Which graph shows the variation of time or potential energy and kinetic energy of the ball? Constant speed means the kinetic energy is the same. So either this is correct or this is correct. These are wrong. Okay, and then it's falling down, so gravitational potential energy would decrease. Now both show the decrease, but what will it be? Gravitational potential energy depends on mgh, so it depends on height, and now we need to check whether height is basically covered or decreasing at a constant rate or not. So velocity is equal to distance over time or height over time. So for each second, velocity is constant, so height will also be constant, which means this should be the answer. Okay, now the maximum useful power of a car traveling on the horizontal road is P. The total resistive force acting is K, where V is the speed of the car, K is constant. Which equation correct traveling at maximum speed? So at maximum speed, the power output should be equal to force times velocity, and this is kv squared times v. Well, that's the force it needs to overcome, right? With kv cube. So v will be equal to p upon k cube root. Oh, they haven't cubed it, so we can directly use p upon k then. P upon k, yeah. So 17 has to be a then. Now, identical blocks of mass m, h are spread. How much work is done on the blocks stacking on top of them? Right. So the thing is that their weight will act from the center, right? So when you keep, like, you put first block on top of another, so it will move here. So which means the height is half h plus half h increase. And then when you put another one, this is plus half h another, and then you put another one plus half h another. So let's try adding them. So h over 2 okay, no, 1 2 3 4 h over 2. So total height would be actually 2h. So now mgh, that would be, right, that should be 2h, but we haven't half h and half h. 4 stacks are there. Interesting. There is, like, every time, okay, wait a second, this can't be like this. So the center of gravity acts here, which is h by 2. So every time it needs to put a stack, so it must move a distance of h there to the new one, and then the new one, and then the new one. So h by 2. So basically doing this would cause h by 2 times 4 because you have to put 4 of them, right? So basically the height will be 2h. Now the thing is that how much work is done on blocks in stacking top of one another. Interesting. This is not, can't be done like this. Let me think about it. So first was right here, doesn't matter. The second was kept here. So you would want to do mgh because this height from here to here will be h. And the third one would basically require movement of here. So that is basically h and 2h. And the third one, then from here till here, that is h, 2h and 3h. Right, 3h. So basically now what are we going to do? There are 3 stacks. H for this, then 2h for the next one, and 3h for this one. So the total height would be h plus 2h plus 3h, which is 6h. So then mgh, so mg times 6h will give you 6 mgh. This is a tough question. Yeah, it is me. You have any questions, please let me know. Okay, now stress and strain graph of wire is shown. What is the Young modulus of material of the wire? So you got to find this point. So stress over strain. Stress is 2.1 times 10 raised to 8 and strain is 1.4 times 10 raised to minus 3. So this is about 1.5 times 10 raised to 11 pascals. Has to be D then. Pretty straightforward. And then 12. What is deduced from the graph? The rubber band does not return to original length. That's wrong. It does return to original length. The rubber band obeys Hooke's law. That's wrong. It should be a straight line then. The rubber band remains elastic for extension. That is correct because it comes back to the same shape. Shaded area worked in extended. That's wrong. Worked in extended is all the area underneath. Okay. Now, which statement about light waves and sound wave is not correct? So light waves and sound wave both demonstrate Doppler's effect. That's correct. Light waves and transverse waves. Light waves are transverse waves, sound, that is also correct. Light waves can be diffracted, but sound waves cannot. That's wrong. Sound can also be diffracted. Okay. Yes, it is. It is 6. Now, which statement is correct? The wave is longitudinal and has a period of 25. Is it so? I don't think so. It has a period of 20, not 25. The longitudinal and the frequency is this. Okay, let's try finding frequency. F equals to 1 upon 20 times 10 raised to minus 3. So 1000 divided by 20 is 50. Okay, this could be correct. The wave is transverse as the amplitude of this. The amplitude is it seems like this. The wave is transverse as amplitude 20. That's wrong. So either this or this is correct. So we got to think why. It is a sound wave. My God, so it has to be longitudinal. Okay, that's wrong. Now, cathode ray oscilloscope is frequency 5 kilohertz. What is the time base? So first of all, you find the time period. So it is 5000. So 1 upon 5000 is 0.0002. Fine. Now time period is equal to time base times the length of signal. Okay, so length of signal here is 2 centimeter. So 0.0002 equals to time base times 2. So it should be 0.00101 seconds per centimeter. Now we need to check which one is correct. Okay, so this means that 0.01 is 1, 2, 3, 4. 1 into 10 is to minus 4. So if I increase 2, so it will be 100 times 10 is to minus 6 seconds per centimeter. Minus 6 is microseconds, so 100 microseconds, correct? Okay. Now, going to the next one. The siren emits sound of 1000. The siren moves at this towards an observer who is standing still. Okay. What is the frequency heard? So observed frequency will be 1000 times 330 divided by 330 minus 20. Okay. This is so easy. Now, a source of sound constant power P is situated in open space. The intensity I of sound at distance r from source is given. How does the amplitude of vibrating air molecules vary with the distance r? Okay, so intensity is directly proportional to a squared. So, and intensity is inversely proportional to r cube. So if I say, then this means amplitude square is inversely proportional to this. So if I take under root on both sides, so amplitude is proportional to 1 upon r. So that has to be a. Alright, now going to the next one. So a detector is moved along a straight line transmitter, direct position maximum minima. The detector distance d, both transmitters are at antinodes. Assume that both transmitters are at antinodes. Which row gives a value d for the maximum and minimum? Okay, so we have the lambda, right? We got the lambda. Interesting. So lambda, a node to node distance is half lambda, right? If there was an antinode on this side, right, so the next antinode will come at half lambda, which is basically 4 centimeter. So instead of doing this, like, we can say that this is a antinode here as well, because this will take a lot of time if we do it like indirectly. So this is two ends open. So what we can do is we can use lambda equals to 2L upon n, right? And then we can keep on checking that at which n we can keep on checking lengths, right? So for this, n is equal to 1, 2, 3, right? So this is 4 times n equals to 2L, and 4 times n over 2 equals to L. So n by 2 is equal to L. So interesting. Value d for a maximum centimeter, a value d for minimum. Now what we can do is we can check n over 2 and put 46. Okay, so I'm putting this. In fact, don't put 46. Yeah, okay, put 46, it's fine. If you put 46, n will be 46 times 2, that is 92. Okay, that seems fair. But if you put like 48, then so 48 times 2 is 96. It should, for minima, it should give you half, but not this. Okay, let me try. I mean, it should give you a different answer, not a answer like this, 1, 2, 3. Okay, so then I could check 47 times 2 is 94, and 48 times 2 is 96. So I'm just writing the answers here, 92 and 96. Here we have 96 and 94. Okay, then we could say 48 times 2 is 96, and 47 times 2 is 94. Okay, yeah. Now with that respect, and let's check, 49 times 2 is 98 and 47 is 94. Okay, now the thing is that I just want to tell you that this is absolutely wrong, because if you check the distance between this and this, so 96 minus 92 is 4 centimeters. So between basically it is not showing me half lambda, it is showing me a full lambda. That is wrong, right? Because lambda is 4. 94 minus 6 is minus 2, and this is 2, and this is 4. So this is also wrong, because between antinode and a between antinode and a node, there should not be half, it should be like a quarter lambda, not this, right? So it's showing me full lambda. So the wavelength from either value of minimum, or I mean from node to node or antinode to antinode, it should give you half lambda, which is 2 centimeter in this case, right? So only these two make sense to me. Now the thing is that which would be before. So if the antinode was formed before, then basically there will be a node, then there will be antinode, then there will be node, then there will be antinode, and like this. So after every antinode there is a node, so it means that naturally the maximum that D would go, antinode is the last one, so at D antinode will have the larger value and node will have a smaller value. So that makes C the ideal answer actually. Pretty good. Interesting. Do you guys understand? Please let me know if you have a question here.
How do you know if it's B or C?
How did I know it's B or C?
Yeah.
Okay, so let me explain it again to you. So this is two end open, right? Because antinodes are forming on either side. Is it clear? Anusha?
Yeah.
Now think about it this way. If that is the case, then lambda will be equal to 2L upon N, right? So lambda is 4 equals 2L upon N. So N would be equal to N by 2L, right? Or you could say N is equal to 2L. Do you understand?
Yeah.
Like that. So I've thought about it. So what I'm doing is, I'm thinking that actually when I multiply 46 with 2L, because this is the length, right? So it gives me 92 on this one, 92, and 48 gives me 96. Is it clear? This is also 96. 47 times 2 gives me 94, right? And 48 gives me 96, 94, and this gives me 98 and 94. Do you understand? Now we are checking, this is the antinode and this is the node, right? So when it is moving from one place to another, I'm just checking what would be the difference between them. So if I subtract these two, what do I get? 4, 2, 2 and 4. Now I should understand that between node to node it is equal to half lambda, and antinode to antinode it is equal to half lambda. Is it clear? Lambda is 4, which means that the distance between successive nodes should be 2, not 4. So that is the reason I cancelled these out and I chose this. Is it clear?
Yeah.
Then I thought that how would I know that which is maximum for what? Because the last point here is the antinode. So before, because it is moving like this, right? Like this. So last point is antinode, so the node would be before antinode. Is it clear? So this means naturally the distance D of antinode should be larger than node. So that's why I chose C as my answer. Do you understand?
Yeah, so the distance for the node should be less than the antinode.
I mean from
right?
the start, yes. Because antinode will, the last antinode will form here, and the last, node will form here, antinode will form here.
Yeah, okay.
That's
Got
right.
it. Thank you.
Understood? Okay. So P is definitely the displacement. Amplitude has to be in the middle, like the maximum. And Q is the wavelength. Oh, it is time period. Okay, it's period. Okay, pretty good. Now, which description of this wave is correct? Seems to me that it is a transverse wave because it is like vibrating up and down. Okay, so it has to be transverse. This is wrong. And this is a node. So half lambda, half. So 1, 2, 3, 4, 5. 5 over 2 lambda is equal to 1.0. So lambda will be equal to, or we can say 100 centimeter. So 100 times 2 divided by 5 is 40. So this has to be the wavelength of a stationary wave is 40. All right. Now, at which point does the complete destructive interference minimum occur? Now let's see. The interference is only happening in this direction, so we're going to look at it. When the solid line and solid line meet, this is constructive. This is also constructive because dotted. So this is like a dotted line and a solid line means. So C is the one where destructive interference is happening because crest and trough is meeting. Alright, so we have the lambda, we have n, and number of diffraction maximum observed on far side. What is the angle between second order and third order? Okay, fine. So d sine theta equals to n lambda. First of all, we'll find d by doing 1 upon 400. So 1 upon 400 is 0.0025 millimeter, and then you got to change it to meters. Okay, so 0.0025 times 10 raised to minus 3. Sine theta, we want to find theta of the second order. So for second order, this is 2 and 567 times 10 raised to minus 9. Okay, let's try. So 2 times 567 times 10 raised to power minus 9 and divided by, okay, I should have used this basically. I messed up, sorry. I should use this. This would make my life much easier. Divided by 0.0025 times 10 raised to power minus 3. Okay, and then I also need to take shift sine inverse of this whole thing. Okay, where is n? Okay, I did put it. So theta for the second order is 27 degrees, and for the third order basically you do 0.0025 times 10 raised to minus 3 times sine theta equals to 3 times 567 times 10 raised to minus 9. So I'll just edit it and put 3 here. So this gives me a theta of 43 degrees. So the change in theta would be 43 minus 27. So that is 16 degree, which is 15.9 right here, because I rounded it, okay. Now, okay, electric field out of bounds. Okay, so a metal conductor has a resistance of 5.6 kilo ohm. Okay, so first of all we want to find the current. So 9.0 divided by 5.6 divided by 10 raised to power 3. That gives me like 0.0016 ampere. So which is basically the total charge. It's 1 minute, right? 0.0016 times 60 seconds times 60. So the charge would be 0.096 coulombs. 1 electron is 1.6 times 10 raised to minus 19 coulombs. Then how many electrons will be in 0.096? So I'm going to divide this by 1.6 divided by 10 raised to power minus 19. That will be 6.0203 times 10 raised to 17. Okay, that's this. pretty easy. And then this one, what is the power dissipated in resistor R? Right, power dissipated in resistor R. So here, because this is parallel combination, now you should know it is 3 ohms total, but you can also try to do it if you're unsure. So this will be 6/2, 3. Now you can use potential divider. We want to find the potential across this. So voltage out equals to 6/6 plus 3 times 12. So 6/9 times 12 is 8 volts. So this gets 8 volts. Power is V square upon R. So 8 square over 6. So that would be 11 right here. Alright, now a box containing 2 electrical components is connected into a circuit. The variable resistor adjusted and measurements are taken to determine IV characteristics. Right, which arrangement 2 electric components in the box would create the best fit IV? Okay, I think this characteristic, this one is for a diode, and because it doesn't allow current, and this characteristic is for a filament lamp. Seems like this to me, and they're in the box, right? So this would only be there if this was in parallel. Then you can't add you can't make their graphs similar, because then they would show you each graph will be different, because then diode will show you this and filament lamp will show you this. So if you combine them, it means they're in series. Has to be D then. Okay, now a cell of internal resistance 5 ohm is connected to a fixed resistor 10 ohm. The resistance of resistor is changed to 20. What statement is not correct? The current in the circuit will be halved. Okay, is the resistance halved? So first the resistance was like 10 plus 0.5 means 10.5. Now the resistance is 20 plus 0.5 is 20.5. Has it gone double? No, it's not double. The double of this should be 21. It's not double. So it means resistance will not be halved. So that is the wrong answer. EMF will remain constant. Power dissipated in fixed resistor will decrease. That's correct, because current will reduce. Terminal potential will increase because resistance at the terminals will increase. That's correct. Now, which row describe Kirchhoff laws? Oh my god, how do I read this? How to read so much? Okay. Sum of current entering junction is equal to sum of currents leaving the junction. Okay, seems correct to me. Conservation of charge, it follows. Sum of EMFs around closed loop equals sum of potential in the same loop, right? Conservation of energy, that is also correct. This is correct. Oh, so thank God they gave me the first one correct. Okay, so okay, now the reading in V1 is 8. Okay, and the reading in V2, where is V2, is 1. What are the readings on other voltmeters? Okay, so this would mean that this would mean that, let's think about it. All the resistors are identical, so let's take 2, 2, 2, 2, 2. If this is 1, this will also get 1 because same, they will divide equally. This means that 1 plus 1, this will get 2 volts total, right? So V4 is 2, and that should be the answer then. Pretty easy then. Okay, then radioactive nucleus emits an alpha particle, beta particle, creating a product nucleus. Which decay would create product nucleus stated? So 226 goes to 224. That's wrong because there should be like there's 4 and 2, so it doesn't conserve mass. 4 and 2. 238, 240. How is it increasing? That's wrong. It should be 234 then. That's wrong. 228, 0 minus 1. 228 and minus 1, 86. It should be 86, not 88. That's wrong. 231, 231. 91 minus 1 is 90. That is correct. Okay, which statement is correct? Electrons and neutrinos are fundamental particles. That's correct. Electrons and neutrinos are hadrons. Protons and leptons not leptons. Proton and neutrons are quarks. That's wrong. Okay, finally done. So I think I will see you in the next class then. Tomorrow will be the last class, alright? See you then. Bye.
Sir, what time?
Say the same time. Pakistan time 11.